All right, we're back with our second learning target of section 4.5, which is graphing polynomial functions in standard form. Now, the reason I chose to place this learning target right here is because we're going to be utilizing factoring in order to find the zeros of these polynomial equations to plot them and sketch their graph. So we've graphed polynomial functions given to us in intercept form before. So now we're just going to have to convert these to intercept form by factoring, talk about end behavior, and then graph them like we have done before. All right, letter A, f of x equals negative 2x to the fourth plus 16x squared minus 32. As always, the first thing I want to do is take out a GCF. Because I am not solving this function, this is just a function, and I'm just rewriting it, we do have to keep the GCF out front. I cannot divide it away like I was when I was solving equations set equal to 0. So when I look at this, I know I can take out a negative 2 from each of those, and that leaves me with x to the fourth minus 8x squared plus 16. And then this situation is one of those that we can write in quadratic form, seeing that we could write this with a u of x squared. So let me just put some x squareds here. So I could rewrite this as negative 2 parentheses x squared squared minus 8x squared plus 16. So I'm going to say let u equal x squared. And remember, if you can do these without u's, feel free. And so that would leave me with a negative 2 parentheses. And we ask ourselves, what multiplies a positive 6, adds to negative 8? And this is actually one of those perfect square trinomials, which would be x minus 4 quantity squared. Whoops, u, because we're using u's. Excuse me. Whoops. U minus 4 quantity squared. All right, now that I've factored it, I'm going to put the x squared back in for the u. Like that. Now this is pretty interesting because what I have here, remember, that's a difference of squares, which means that factors to x plus 2 times x minus 2, but that's being squared, which means that those factors each show up twice. So I'll just put that in a big set of parentheses. That's x plus 2 times x minus 2 in parentheses squared, which means I can write those as f of x equals negative 2 times x plus 2 squared times x minus 2 squared. So this is actually a pretty fun graph because if we remember, we get our zeros from the factors. What makes each of those equal 0? And this one would be x equals negative 2, and it's a double because it's squared. And this one would be x equals positive 2, and it's also a double because it's squared. So remember, double zeros bounce off the x-axis. So I'm going to plot those at negative 2 and positive 2. Now, to draw my graph, I have to think about degree and leading coefficient. Now, we could have done that right at the beginning here. To figure out your degree and leading coefficient, when it's in standard form, you can just look at your first term. The leading coefficient is negative 2. The degree is 4, which is even. Remember, even degree, your ends go in the same direction. So they'll either both go up or both go down, but because my leading coefficient is negative, they're going to both go down. So let me get back to my graph here. I'm going to be starting down, so like down here, and I want to end over here. And I cannot cross at these 0 values, I just have to touch. I come up, touch, come back down, come back up, touch, and come back down, and put arrows at the ends. And that is my first graph. All right, let's look at letter B. F of x equals 3x to the fourth minus 6x squared plus 3. Looks like I could take a 3 out of all those. So let me write this. Whoops. F of x equals 3 parentheses x to the fourth minus 6. Oops, I didn't divide that by 3. That would be a 2 minus 2x squared plus 1. Now this one is a lot like the previous one because this is x to the fourth, x squared, which means I can write this in quadratic form and use u substitution if I would like. So I can write this as 3 times x squared squared minus 2 times x squared plus 1. So I could say let u equal x squared if I would like to, and write this function as f of x equals 3 times u squared minus 2u plus 1. And this is actually another perfect square trinomial because what multiplies a positive 1 and adds to negative 2? That'd be a negative 1 and a negative 1. So that's just 3 times u minus 1 quantity squared. And then I'm going to put that x squared back in there. I'm going to come up here, make sure I have enough room, and say, all right, f of x equals 3 parentheses x squared minus 1 parentheses squared. Now this really is a lot like the previous one, and now I have another difference of squares. So just like I had up there, f of x equals 3 times, this would be x plus 1 times x minus 1, and that's squared. So both of those factors are actually squared. So 3 times x plus 1 quantity squared times x minus 1 quantity squared. So here's my function. My factors, I get the 0 values of x equals negative 1, which is double, and x equals positive 1, which is double. So negative 1, positive 1. And now to decide my end behavior, I look at my first term right here, 3x to the 4th. My leading coefficient is 3, which is positive. And my degree is 4, which is even. And remember, even degree, same direction, positive, they're both going to be going up. So starting up and coming down, I bounce off of negative 1, come back up, bounce off of positive 1, and come back up. And there is graph B. All right, last one. F of x equals x cubed plus x squared minus 6x. Looks like I can take an x out of all of those. F of x equals x times x squared plus x minus 6. Here's just a run-of-the-mill trinomial. I don't have to do any u substitution, thank goodness. That factors to x plus 3 times x minus 2. So I have 3 0 values. I have from this factor x equals 0, x equals negative 3, and x equals positive 2. So there's negative 3, 0, positive 2. And before I draw, I have to figure out my leading coefficient. Looking at my first term, which is just plain x cubed, is 1, which is positive. My degree is 3, which is odd. Odd, positive. Odd is opposite directions. Positive means ending up. So starting down, ending up. And all of my zeros are single zeros. So I'm going to just go through them. So starting down here in quadrant 3, I'm going to go up through negative 3, back down through 0, and back up through 2. And that is graphing polynomial functions in standard form.